Hello guys, my name is Engineer Holiday. You are welcome to this class. We want to deal with a special case, and that case is we want to see when the body is acting or when the body is being pushed by a force. How do we calculate and how do we solve problem like that? And they said a block 25 kg is pushed, in this case 3, is pushed a distance of 5 meters along the level floor at a constant speed by a force at an angle 30 degrees to the below the horizontal. The coefficient of friction between the floor block and the floor is 0.4. Find the pushed force and the work done. Now first we illustrate with a diagram to see clearly what the question is saying. And each 25 kilogram, we know the weight will be mg. Weight equal to mg, which is 25 times 10, and that was 250 newton. Now, then the reaction be going upward, which is R. Now they said it's pushed what? Now when they say something, they will push the body below the horizontal. It means pushing below is also what? Pushing below is also the same thing, is the same as pulling below. While pushing above is the same thing as pulling above. So this one now, pushing below, because it will end up, this is it, with a what? At the angle of what? 30 degrees. Now, if you want to pull below, this is pulling below, which is the same thing as 30 degrees. So, pulling below and pushing below, this is or below the horizontal is the same thing. While pulling above and pushing above is the same thing. So this is it. What force? Let's call it P. So let P be equal to the what? The force pushing what? The block at 30 degrees to the horizontal. Now, I haven't done that now clearly. Now let's resolve horizontally and resolve vertically. For the what? If you resolve this P horizontally, if you resolve it, it will not be going that way. The direction will not face that way. And if you resolve vertically, it will face down. Look at the arrow. The arrow will tell you a lot about where the direction will go. So here we now do what? P cos 30. If you resolve this thing, because it's inclined to the horizontal resolution will be cos. The here will now be what? P sin 30. So we have what? P sin 30 going down. Then this is the weight. Now, having done that now, the frictional force, because this surface is a rough surface. Let me clean this one. It's a rough surface, so which is 0.4. The mu is equal to 0.4. Now, don't forget, the frictional force will act in this way. Why? Because it's what? Motion is likely to go that way, forward, so it will go back. Friction will not be Fr against. Now, we have gotten all our forces from the box, from the block. Now, with sigma Fy must be equal to what? 0. Why? Because what? Of constant speed. Don't forget, also, similarly, sigma Fs equal to 0. Because acceleration is equal to 0 on both x and y components. Now, let's resolve. If we resolve along the what? Resolving vertically. So if you resolve vertically, we are going to have what? The R is going up. Check the reaction. The reaction is going up, which is what? R. Then how many weights are going down? or forces are going down. This one is going down because per sine theta, and 250 is going down. So it's equal to downward force. Upward force is a reaction equal to downward force, which is 250 Newton, or 250 plus what? P sine 30 degree. So let's call this one equation 1. So now resolving what? Horizontally, resolving what? The force or forces horizontally. What do we have? We are going to have it as what? Horizontal force. This is only force going here. But when this one is only force going here. So backward force equals to forward force. So that will now give us FR is equals to what? P cos 30, or P cos 30 equal to FR. And don't forget, FR equals to what? Mu R, which is, that means P cos 30 degree. Now, FR is what? Frictional force, which is equal to coefficient of friction times normal reaction. 0.4 times R equal to P cos what? 30. Recall that, let's call this one equation 2. Now, listen very well and listen go so good. We are giving what? A coefficient of friction, which is what? Which is 0.4. That should be coefficient of static friction because of this statement. Now, what do we do now? Let's put equation 1 in 2. Anyway, we see R, we substitute R here by replacing what? R with 250 plus what? P sine theta. We then have what? P cos 30 degree equals to, do that accordingly, 0.4 into bracket what? 250 plus what? P sine 30. Please, if you know you are enjoying this class, just click the notification button and subscribe to our channel as you watch. God bless you. Now, we have what? P cos 30 degree equals to what? This 0.4 times 25. We are going to have 100 plus what? 0.4 times P times half. Don't forget, sine 30 is half. This times this is 100. This times this is what? And that will give us 0.2. 100 plus what? 0.4 divided by 2 is what? 0.2 P equal to what? P cos 30. Cos 30 is what? 0.8660 P. And let's collect like terms. If you collect like terms, we are going to have what? 100 will remain there. Then, or let's say we bring this one here, we are going to have 0.8660 P minus 0.2 P equal to 100. So how do we make our P, which is our force that we are looking for, the pushing force or the push force, which is what? So now it was 0.666 P equal to what? 100. If you divide both sides by 0.666 divided by what? 0.666, then divide both sides by that, P becomes what? 150.15. So you can confirm it and get your answer. 150.15. Now, having gotten 150.15 Newton as our force, we want to solve for the second question, which says what? Work done. You have find the push force and the work done. And the work done normally is what? Work done is equals to P cos theta times perpendicular distance or time parallel distance. How? If you check the diagram, let's go to the diagram together. P cos 30 is the force that will move the wall, that will push the wall, the block, a distance of 5 meters. So that distance D is 5 meters. We have gotten our P, which is a very important parameter to get. 150.15 cos what? Times cos 30 times 5. So what do you have now? If you press your calculator, you will have 150.15 times 0.8660 times 5. And the answer will be what? 150 times 0.860 times 5 will give us 650 joules. That's our answer. So that is a work done. We have solved for the number 1 question, and this number 2 question, which is a work done. So the push force is 150.15. The work done is 650 joules. Thank you very much for watching. God bless you.